In lecture number 25, 26, 27, we will be discussing loops such as while loops and do while loops and the for loops, which are used for iteration or if we want to repeat some statements. Before seeing this lecture, you must see the recorded lecture number 7, or sorry, live lecture number 7, in which I have discussed the introduction of the loop. Just to recap what we did in live lecture 7, this is simple a while loop, and as long as this condition is true, it will keep on repeating these statements again and again, and we have seen how these statements actually work. We have declared I equals to 10, initialize it to 10, and I 10 is greater than 0. So this condition is true. It's going to see out some statement, and then it will decrement the value of I. Then now the value of I is 9, and it's true. So it will just keep on repeating this thing, and in each iteration or in each going through this loop, the value of I is going to be decremented, and in the last iteration the value of I would be 0. So 0 greater than 0 is false. So the program the program control will exit this loop. So just take a look at this example. We are using a while loop to compute a sum of consecutive integers, and here we have declared the integer n and I equals to 1, and we are just saying that enter a positive number, and we take that number from the user, and now we have declared a long integer, or maybe if you want to, you can just do a long integer, and we have declared it initialized to equal to 0. Now what we have done here is that we are using a single statement for the while loop, so if we do not need any curly parentheses. If you want to, you can use curly parentheses over here and enclose that here, but since we are just using a single statement, so this while loop ends at the very first semicolon right next to the I plus plus. So this I is equal to 1. So what we are going to do is that it starts from 1 and it is actually less than equal to n. Let's say the user has pressed 5. So I1 is less than 5. So we are going to say the sum initially was 0. So 0 plus 1, which is I, it will be 0 plus 1, that will be 1, and then I would be incremented to 2, because this is a post increment operator. If you do not like this thing, you can just do it in two statements. I could have written sum equals to sum plus I, and in the next line I could have written I plus plus. I mean, they mean exactly the same thing because we are using the post increment operator. So the value of I is going to be used first, and then it will be incremented. So the value of sum would be right now 1 in the first iteration, and then the I plus plus would happen, and the value of I would be now 2. So 2 is less than 5 because the value entered by the user was 5. So this condition is still true. So the sum would be updated to 1 plus 2, that will be 3, and I would be updated to 3. I is still less than 5 because 3 is less than 5. That is okay. So we enter the loop again, and that that next value of I is added to the sum, and I is incremented as long as that is equal to or less than n. And after that, when the value of I exceeds the value of n, this condition would be false, and the program control would be transferred outside the loop. So let's run this thing, and it says enter a number, enter a positive number. I said 5, and it says that the sum of first 5 integers is 15. I have changed the compiler to debug version, added the watches for I equal and sum and n, and I have added the breakpoint at any line, and I mean initially in the first few lines actually, and I'm going to press debug here, and it says that I equals to 0 and sum equals to 4, because we have not actually, this is from the previous execution. So let's run this thing line by line, and it says after n, it declared the value of n, and I is actually equal to 1, and enter a positive integer. And I mean, just ignore this value because this is just garbage value. We haven't not even declared the variable yet, so this is from some previous execution. So we are going to say enter positive number, and we just take the number cn. After running this, I am going to enter the number. Let's say I've said price, 5, and then it goes to the next line, and it says long sum equals to 0, and after running this line, it will initialize the value of sum to 0. Now this is correct. So now we need to watch this process carefully. It's not going to see out anything unless it exits this loop. So we just it's going to check whether I is less than 5, which is if you just hover the mouse over here. So I is less than 1, I is 1, and n is 5, so that is okay. We go to next line, and it updates the value of sum to 1. Then it again n updates the value of I to the next value, which is incremented. So I is 2, and that is less than 5. so that is okay. So it again runs this line, and the value of sum and I is updated. First the value of sum is updated, and after that the value of I is updated. So we need to watch out these this window as well. So go to, I mean, this condition is still true. 3 is less than 5, and it will just again run this line. And now 4 is less than 5, which is the value of I, which is again runs this line. And 5 is less than equal to 5, that is also okay, and again runs this line. And now the value of I is 6, so 6 is less than 5. That is not true. So the control of the program is transferred outside this loop, and the loop actually terminates, and it's now going to run this line, and the sum of the, and after running this line it goes to return 0, and the program ends. So the sum of the first 5 integers is 15, and the program ends after running this line. It says the program, I mean, just ends over here. So this is the explanation for the simple while loop, using this while loop to some numbers. Similar thing happens here, where using a while loop to compute a sum of reciprocals, which is just saying that we are just going to enter a number saying that sum all the reciprocals of like 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 and all the way to some limit, as long as the sum remains within the bound which is taken by the user. So let's run this code. So we are just going to go compile and run here, and it's going to say, and let's say I just press 3, sorry, I just press 3, and it says the sum of first 11 reciprocals is 3.01988. So it's going to add 1 upon 1 plus 1 upon 2 plus 1 upon 3 1 upon 4 all the way to 1 over 11, and once the limit exceeds whatever the user has entered, which is as bound, and then the loop is exited. So let's run this code. I mean, it's pretty simple. So what it's saying here is that enter a positive number, we take that as bound, which is essentially an upper bound, and we take the double because the sum would be a fractional number with a decimal part, so we have to take it as double, and integer I equals to 0, which is simply a counter, and we say while run this code. I mean, this loop is just simple this line, and this is the condition, while run this code as long as the sum is less than bound. So sum is equal to 1 upon plus I, so I was 0, so 1 upon 1 would be added. I mean, you cannot do I plus plus here, because in that case that would be 1 divided by 0, and then the value of I would be incremented. So this is a divide by 0 error, so that's a maybe a compile, I mean, that would be a error, maybe a compile time error or maybe a runtime error. You figure that out, but I mean, you should not be dividing it by 0, because the value of sum would be infinity or INF. So now I mean, if you keep on adding the numbers, the value of sum would remain at INF or infinity. So 1 divided by plus I, 1 divided by 1, and that is 1, and the value of sum would be updated to 1, and in the next iteration value of I is 1, it will be incremented to and then we will be adding 1 upon plus I, that would be 2, so we'll be adding 1 upon 2 plus 1 upon 3 plus 1 upon 4, and as long as the value of sum is less than bound, it keeps on adding those numbers. Looking this code in the debug compiler, and we just change the compiler to debug, and says enter a positive number. I'm going to go to the next line, and it's going to say enter a positive number. Let's say I press 3 here, and sorry, after running this line it should say enter a positive number, which is so that will be a big number, and let's run this code here, and let's write a debug, enter a positive number, that is a C out. After running this line, it's going to say enter a positive number, and after running this thing, we should be taking the input, which is 3 here. Okay, so we just enter, and that bound is taken at 3. I mean, just forget this thing, this is from the previous execution. So after running this line, the value of sum would be updated to 0, and integer I is declared, and after running this line, the value of I would be initialized to 0, and it's going to check whether sum is less than bound. 0 is less than 3, that is okay. Now watch what happens as long as, and we need to keep in mind this thing, and we need to keep in mind this thing. Okay, so after running this line, it just checks the condition and enters the loop, and after running this line, line, the value of I is incremented, the value of sum is 3. So it just keeps on doing this as long as the value of sum is less than bound. So here the value of sum is less than bound. It keeps on adding these fractions, 1 upon 1 over 9, and then 1 over 10, and now it's going to add 1 over 11. And after running this line, the value of sum is now is 3.0198. It is not less than bound. So the execution of this, the control of the program is going to be transferred outside this loop, which is outside this semicolon, because this is a single line loop. So we just go to the next line and say cout, and after that this cout, the first of some 11 reciprocals is 3.01988, and after that this goes to just terminates the program. In this code, we are just using a while loop to repeat a computation. I've discussed this concept in the calculator program, in which I was taking the input from the user, and if the user entered some 0 or some special key, we could just say that quit the program. So here it says that enter a positive number. We are just computing a square root, so that for that we need to include the CMath library, and we are going to say that enter a positive number, and that number is assigned to x, and as long as x is greater than 0, so that the square root is a real number, we are going to say that the square root of that number is square root of x. Now we are just going to say enter a positive number or 0 to quit. So if the input is 0, so 0 greater than 0 is false, it's going to exit the loop, otherwise it will keep on repeating this loop again and again. So let's run this code quickly, and we say enter a positive number. Let's say I press 5, it says square root of 5 is whatever the number, and it says enter a positive number, another positive number, 0 to quit. I said, say I press 9, and it says square root of 9 is 3. I press 11, it says square root of this thing. If I press 0, so 0 greater than 0, that condition becomes false, and it will exit the loop. In this code, we are using something known as a break statement, and it comes after, if this condition is true, usually we have some kind of a condition, we are going to check that condition, and if this condition is true, if we write break, that will terminate the loop immediately. It will not run rest of the lines, it will not go to the checking whether this condition is true or false. It will just transfer, if this condition is true, it's going to run this break statement, and the control of the program is transferred immediately outside the loop here. So this break statement terminates the loop immediately, and we have written an infinite loop here, because we are saying that while this thing is true, so we can just write 1 in place of this true, or I could have written 1 or maybe true if you want to run this loop indefinitely. So obviously you need to have some kind of a terminating condition within the loop. So we are saying that if the value of I is greater than n, then break immediately. So this is the same program in which we take the input from the user as a number, and we add the numbers up to that point, and we are saying that the sum of first whatever numbers user has entered integer is whatever the sum is. So we need to have, instead of writing, we could have written the condition here, which we did in the previous program, to some integers, and which we discussed in the very beginning of this lecture, or we could use this true, which is essentially an infinite loop, but here it's not infinite anymore, because we must have some kind of a terminating condition. In this program, what we are doing here is we are computing the Fibonacci series of Fibonacci numbers, which is actually the sum of the next number is the sum of the previous two numbers. It starts from 0, and then it goes, and the next number is 1, and the next number is 0 plus 1, which is 1, 0, 1, 1, and the next number would be 1 plus 1, that is 2, and the next number would be 1 plus 2, that is 3. So that will be 0, 1, 1, 2, 3, 5, 8, and so on and so forth. So Fibonacci series or Fibonacci numbers are found everywhere in the nature. So here we have what we are doing here is that we have the first number is 0 and the next number is 1. We have to start somewhere, so we are starting at 0 and 1, and we are saying that this condition is true. We are just written true, and then what we are doing here is that this f2 is the sum of the first two numbers. So f2 would be 0 plus 1, f2 would be 1. So what we are doing here is that we are taking the number, the limit of this Fibonacci series or Fibonacci number sequence from the user. So as long as this f2 is within the bound entered by the number user, we are just going to keep on generating these numbers. So this f2 is if this f2 exceeds the bound, we are going to break this loop. So the control of the program is going to be transferred outside this loop, and this will terminate the loop immediately. So if this condition is false, this statement, this break statement is not going to run. We are going to say C out and whatever that number is, and then we are going to replace f0 with f1 and f1 with f2. So f0 and f1 is the would be having the next value. F0 would be having the next value, and F1 would be having the next to next value. So we go again, and this condition is true. So if we enter the loop here, so F2 would be the second value, and the third value would be added, and as long as it is less than bound or equal to bound, this condition is false, so it's not going to run the break statement, and when we output the next value. So let's run this code, and it says that enter a positive number. Let's say press 10, and it says the Fibonacci numbers less than 10 are 0, 1, 1, 2, 3, 5, 8. So I mean, because the next number would have been 8 plus 5, that would have been 13, and that would have exceeded the bound. In the next example, we are using something known as an exit function. So exit function, what it does is that it terminates the program immediately. Here we are using the break statement to terminate the loop. Here what we are doing is that it will terminate the program immediately. It will not transfer this thing outside here. We are just essentially calling the return 0. We are exiting the whole program. I mean, whatever code you have written outside this loop or outside next to this line is never going to be executed, and whatever is written over here is not going to be executed. Here I mean, if you have written some C out statement or some other thing, that would have broken the loop, and the control of the program would have been transferred at this point, and whatever the code we have written here would have run. But here, if this condition is true, we are exiting the program altogether. So we have the same result, but there's a difference between the break and the exit is that the break is going to terminate the loop in which the break statement is written, but the exit 0 function is going to terminate the whole program. This whole program is going to be terminated. No line next to this line is going to be executed. I mean, the whole program would terminate immediately. So if you run this code, we are going to get the same result. Which says that let's say if I press 15, actually due to the antivirus, if I just press 15, it says the sum of Fibonacci numbers less than 15 are 0, 1, 1, because each next number is the sum of the previous two numbers. It starts from 0. 0 plus 1 is 1, 1 plus 1 is 2, and 1 plus 2 is 3, and 1 plus 2 plus 3 is 5, and 3 plus 5 is 8, and 5 plus 8 is 13. Now 13 plus 8 is 21. So that would have been exceeded. That would have exceeded the value of this bound entered by the user. So if we go to this thing, I mean, we here we are not we have not included any break or any exit condition of this loop. So it's important that if you are running, if you have written the condition of the loop to be true, you have to be you have to make sure that there should be some kind of an exit condition to terminate the loop. There should be some kind of a break statement to terminate the loop. If we haven't written this thing, so let's run this code and see what we get. It says it says enter a positive number. If I press maybe 12, and it just keeps on generating those Fibonacci numbers, and I mean, really quickly, because this long integer is a 4-byte number, it will just cycle it back after 2 point some billion. So this thing is an infinite loop, so we need to press Control C to terminate the program. So let me repeat that it's absolutely important to have some kind of a exit or termination condition in the loop. If you can write this condition here, run this loop as long as this thing is true, and if you have written true here explicitly, then you must have some kind of a break or an exit clause inside this loop, so that the loop terminates. It doesn't run infinitely. And this is actually a do-while loop. I mean, the do-while loop here is there is a slight difference between do-while loop. Here the do is, I mean, let me in the while loop, the condition was being checked before entering the loop. in the do while loop, the condition is not checked before entering the loop. It will enter this loop and then it will check the condition. So that means that the control variables which are being used here can be declared inside this loop body. If the in the while loop, you have to, the control variables are in the while loop, the control variables have to be declared outside the loop body, because they have to exist before you are going to check whether they are true or not, comparing with some other values. But in the do while loop, you can declare the control variables inside the loop. Another benefit or another feature of the do while loop is that if you want to run this code, even if the condition is false, the do while loop will run this code at least once. This code inside this loop body is going to run. I do not need this curly bracket because this do while loop has just one statement as terminated at this semicolon. But if you want to run this code at least once, even if the condition is false initially, this do while loop will do the job. While loop will not do it, because while loop will checks the condition first and then enters a loop if the condition is true. But the do while loop doesn't check first. It enters a loop, executes whatever is there, and then at the end of the loop it will checks the condition whether that condition is true, and then it will again repeat this whole process if the condition is still true. Another small difference is that here you need to write a semicolon, but if in the do while loop, in the while loop you did not need to write you do not need to write sorry, this is a for loop. You do not need to write the semicolon right here, because that would be a syntax error. Coming back to do while loop, it's just summing the numbers exactly the same. We are saying that run this code as long as this condition remains true. So it's just summing, taking the input and just saying that the sum of these numbers is this. I should have declared it a long sum, but you get the idea. So let's run this code. We get the same result. Enter a positive. Let's say if I press 10, it says that sum of first 10 numbers is 55. It says, it just updates the value of sum, and then the value of I is used, and then the value of I is incremented, because it's a postfix increment operator. So the value of sum is updated, and as long as the value of I is less than n, and because the value of I initially was 0, and then it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and after that this condition will become false, and the program control will transfer outside the loop at this point. In this program, we are computing the factorial numbers less than the bound entered by the user. So we are taking the number from the user and assigning it to bound, and saying that factorial numbers, which are essentially the number 4 factorial is 4 into 3 into 2 into 1, and 0 factorial is 1. So I'm just printing the value of 0 factorial as 1, and then I'm going to print the value of 1 factorial, 2 and 3 and 4, 5, whatever the numbers are, up till the as long as the result of that factorial number is less than the bound entered by the user. So first let's run this code, and it says enter a positive number, and it says, let's say if I press 100, and it prints all the factorial numbers, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 5 factorial as well, which is 120, which is actually more than 100. To figure out why it's actually printing the value more than 100, even though the logic says that here the value of f is 1, and I'm just incrementing the value of I first. I could have written this line or this line in the first line, and it would have incremented the value of I in the anyway, and then I could have written this line. Instead of writing these two lines, I have written this line. So incrementing the value of I first, which is 1, now it's going to be 2, and this and 2, and this is going to be multiplied it by value of f, which was 1, so that would be 2 factorial, and then that would be 3 factorial, and so on and so forth. So in the next iteration, the value of I would have been 3, and 3 into 2 would have been 6, so we have printed 6 here. And as long as the value of f is less than bound, value of bound, so this loop would have run correctly as long as this condition is true. The difference is that this do while loop first runs this code and then checks the condition. So to figure out why it's actually printing 120, so I'm going to compile this thing in the debug, but not in the release version, but with the debug version of this compiler, and then I'm going to view the report window, which is here. Let's have the debug menu here, and then I'm going to see the project manager, which is right next to it. So I'm going to add a few watches. This f is going to be add watch, and I is going to be add watch over here, and I think bound is okay. So let's have the, because bound is going to be fixed, right? So I'm going to add the watch for bound as well. So let's debug this thing. I've added the breakpoint here already. So here nothing is being say after running this line is going to say enter the enter a positive number, and that thing is displayed here, and then it's going to run this line, and after running this line I'm going to enter a number, for example 100, and press enter, and this thing is going to see out this line, and the next line would be factorial number less than 100, 1 comma 1, so that is 0 factorial and 1 factorial. So here it would be now 2 factorial. So the value of, I mean, these are just garbage values because they are not initialized yet and not even declared yet. I mean, this is just I mean, this is absolutely nothing. After running this thing, the value of the f and I would have been updated correctly. So let's go to next line, and now the values of f and I are 1. So now we need to watch the value. So now, we need to watch what is going on here. So let me have these windows side by side, and let's run this code. So we need to watch what cout is being printed. So if this is going to multiply, it's going to increment the value of I first, and then the value of I would be 2, and f into I would be 2. So if we just press the next line, it says the value of I is incremented, the value of f is also updated, and it's going to see out this line which is 2. So that is here, and then it's going to check whether this f is 2 is less than bound, which is 100. So it's going to, and that condition is true, so it's going to again run this whole loop. So it's going to update the value of I and then multiply it with the existing value of f. So the value of I is updated to 3, and 3 into 2 is now 6, and the value of f is printed, which is 6. So if I go to, I mean, this thing is still true because 6 is less than bound, so it again repeats this whole cycle. Value of I is updated, would be updated to 4, and 6 into 4 would be 24. Value of f is updated, and the value of f is 24, and it's now going to be printed out on the screen. So this thing is 24. I mean, ideally the loop should stop right now, because 24, I mean, we should want to, but I mean, looking at the condition, 24 is less than 100. So this, as far as the computer is concerned, this thing is true, because 24 into 5 would have been 120. So it's actually what we want to print is the values less than, the factorial numbers less than 100. We want to print those numbers, but here the value of f is 24. So it's going to run this code again because the condition was still true. So it's going to update the value of I, which is 5, and 24 into 5 is 120. The value of I is f is now 120. Now it's going to check 120 is less than bound, which is 100, which is not true anymore. So it's going to exit this loop body, and the control is transferred right next to it. So this thing is printed here. So what we are going to do is that it's actually printing. So let's add a check before printing this thing. So if I write if f is greater than or equal to bound, BOU, and is bound, we are going to say, look, break the loop. So if I run this code again, it says enter a positive number. So positive number is 100. And now it's true, because I mean, now even if it checks whether this thing is actually more than this thing, so it's going to break. So I'm going to run this code again in the debug menu, and debug, I'm going to add watch here. So we just need to figure out these we need to watch out these numbers. So it says enter a positive number, that would have been entered here. So I'm going to press, after running this line obviously, so next line, and I'm going to press 100, and so watch out these things. Okay, so it's says next line, the values of f and I are updated correctly, and bound is actually equal to 100, and it's going to multiply the value of f. The ones and ones were printed before in the normal cout statement, and it's going to check whether this thing is actually f is actually greater than equal to bound or not. So it's not, so it's going to print the value 2. It's going to check whether this thing is less than bound, that is okay, so it's going to repeat, it's going to check, it's going to update the next value, which is 6. It's going to check, that is also true, repeat the whole thing, and this is 24. Now watch out the value, it's actually 24 is less than that, so it's true. So the value of f is updated after running this line. The value of f is updated to 120, but we have added the break clause here. Look, if this thing is more than 120, just break the loop, so that this break statement will terminate the loop and the control will be transferred outside this loop. So it will just break the loop because this condition was true and the control is transferred outside the loop.